So the Chapter 9 practice test, I know it says Form A on there. It should say Form P because this is the practice test here. But these that we start off with are just, can you tell the difference between an arithmetic, a geometric, or a neither? And can you write both a recursive and an explicit formula for each of those sequences and find the 10th term? Now, that's a lot of stuff, but we put it all together as we go through it. So first things first, let's look at number 1. What do you think? Are they adding the same thing every time, or are they multiplying? They're adding? What are they adding? They are adding 6. So what kind is that? Arithmetic. Arithmetic. So then, you'd go down to the formula sheet and you would look for your formulas for recursive and explicit arithmetic formulas. And remember, they're the ones with the pluses. But with recursive, we always have to tell them a place to start. So we have to tell them the first term is 23. And then we always have to say, to find any term, do something to the previous term. Well, what do you do to 23 to get 29? You add 6. So that one's done. So recursive is kind of like how you would explain to somebody what you see. Hey, they're adding 6 every time, but we have to put first term and then a sub n. Explicit, that's why there's a little bit of room down here, because the explicit rule is the one we really like. That's going to get us any term they want, any term. And all we have to do is put the first term in there and put d in there. And we actually already found those two things, you know, right up there. So what was the first term? And what did we say they're adding every time? And then we need to simplify that. Can't leave it like that. It looks awful. So we're going to distribute the 6. 23 plus 6n minus 6. And then we're going to combine like terms. So what's 23 minus 6, everybody? 17. So that's the explicit rule. That's going to go right here. And it's a good thing there's little blanks to remember or to remind us to do all these things, because there's a lot to do in this problem. So now we have to find the 10th term. So what would we do? Yeah. Oh, because I looked down here and I saw my equals and thought it was a negative. Thank you. I didn't see the other part to my equals. There we go. How do we get the 10th one? Throw a 10 in there. So 6 times 10 is plus 17. There it is. So it does all fit together. It's kind of like making you do step 1, step 2, step 3 as you go through it. But that's what we need to do. Alrighty. Problem number 2. Are they adding the same amount every time? No. No, because 5 to 15 is plus 10, and 15 plus 10 is 25, not 45. Are they multiplying by something? What are they multiplying by? 3. Making it what type? Geometric. Geometric. So now, you're going to have your formula sheet, and you look at it and say, okay, I need the formulas that have an R in them. So no pluses, because that's the arithmetic stuff. And you're going to see that it says to do the first term, which is a 5. I mean, you have to tell them where to start for recursive. And then, to find any term, do this to the term before it. What did we say they need to do to it? Multiply it by 3. So we'll put a 3 in front. And it'll say, take 3 times whatever term you already have. But now that one, if they say find the 500th term, we're not going to be very happy. So we'd have to go for the explicit rule. And I know that it has an R in it, so I look at my formula, and I see it's a sub n equals a sub 1 times r to the n minus 1 on the sheet. Do we know the first term? Do we know r? Well, it's like this thing's going to write itself. a sub n equals 5 times 3 to the n minus 1. So that goes right here. 10th term. What do you want to do? Yeah, and that's where we'd want a calculator, right? So a sub 10 is going to equal 5 times 3 to the 10 minus 1, which is the 9th power. So 3 to the 9th, and then times 5. 98,415. Now that might make me a little uncomfortable if I'm taking a test. Was that supposed to be a big number? You wouldn't think about it, you just write it down. Well, if we're going to multiply by 3 every time, won't the numbers get kind of big pretty fast? So yeah, the 10th term should do that. Yeah. All right. Now the problem we're going to love to hate. You got to do a trial and error problem on the test. So that means I'm flat out telling you, well, you can see, we're not adding the same thing every time, right? And if you try to find r by taking 17 over 15 equals 20 over 17 equals 24 over 20, no, it doesn't. So now we have to go back to, how did we do these before we knew the formulas? Anybody remember? N equals and a sub n equals, and we're going to look at the chart and try to figure out how could we tell somebody how to get this. So the first one, second one, third one, fourth one, I need another space. Now it says recursive rule, so we have to tell them what to start with. What was the first term? 15. So that's a big part of this. It did not start at 0. We have to tell them, hey, it started at 15. Now, hopefully, we can look at the chart, and you guys already started. You said you see the plussing, right? You see the adding? Plus 2, 3, 4, and 5. And think about where up there you could get a plus 2, a plus 3, a plus 4, and a plus 5. Isn't that right here? 15 plus 2 is 17. 17 plus 3 is 20. 20 plus 4 is 24. 24 plus 5 is 29. The previous term plus n equals the next one. So to find any term, take n plus the previous term. Or you could write a sub n minus 1 plus n if you want to put the n in the back. You could do that. Now, we have to find the 7th one. Well, that's only 2 away. $29 plus 6, 35. 35 plus 7, we've got it. And yes, we did try to put a reasonably basic one on the test. You know, something that without too much staring at it for a long time, you should be able to do it. Now, if these are tough for you, skip it when you're going through the test and come back to it at the end. You know, don't let yourself get all frustrated with this and get bogged down on it for too long. So if you know this is going to be a tough one for you, come back to it after you've done all the other problems and you've used all the formulas you possibly can. All right. So far, so good? Okay. Ready? Let's give this one a try. Find the first 5 terms of each sequence. Oh, that's all you do? That is all you do. Put a 1 in, see what you get. 2 times 1 is 2. 2 plus 3 is 5. Put a 2 in. 2 times 2 is 4. 4 plus 3 is 7. Put a 3 in. 2 times 3 is 6. 6 plus 3 is 9. And maybe at this point you don't need to keep putting numbers in. Do you see the pattern? Going up by 2. And then we come over here and we write 5, comma 7, comma 9, comma 11, comma 13. And we have it. What type of sequence is this? It is. Yeah, basically we're just adding 2 every single time. So remember, they look like lines. That's what they look like in the equation. 5 does not look like a line. Do you know what type that one is? It is geometric. Something times something to the n minus 1 power. How are we going to get the first term? Yeah. 1 minus 1 is 0. What's anything to the 0 power? So 3 times 1 is 3. Put a 2 in. 2 minus 1 is 1, so that'll be 4 to the first. 3 times 4 is 12. Or we could have found that one a different way. What are they multiplying by every time? 4. This is R. So instead of continuing to use the formula, we'll take 12 times 4. Take 48 times 4. Don't want to do that in my noggin this morning. And take 192 times 4. And then we go fill in the little blank. Easy peasy lemon squeezy? Okay, good, good. All right. Now let's get your memory banks working. All we need is the middle one. How do we find it? How?
Didn't we learn this with guy? Like the guy who was here?
Yeah, but the geometric one. This you learned with me.
Okay. I didn't
Really? Is that it? Yeah, that's the arithmetic mean. The mean is the average. So we add those 2 little buggers together, we're going to get 50 divided by 2, which is 25. But geometric mean, a little bit more work. You remember the 2 spots for the means?
Oh, hold on, maybe. Okay, 45 on the top on the left and 45 on the bottom on the right.
Beautiful. Because the 2 middle positions. Oh, did you have them backwards?
No, I said 45 for both the top and the bottom. So
Oh, okay.
I'm close.
Yeah, yeah. And then cross multiply. Oh, that does not look like a 2. 45 times 5. Yeah, that's a nice number. Because what do we have to do to it? Square rooty toot toot that. And make sure we write plus or minus 15. Because without another number in that sequence, we don't know whether or not it would be positive or negative. We've just got to say, hey, it might be this. Still good? Sounded like some of you maybe need to star those 2 so you can go back and take a look at those 2. You know, if it didn't come immediately to you, then you might want to star them. All right, let's see. How many problems do we have on this thing? So, yeah, we better finish up a little bit more. Tomorrow we'd have more time because we won't have homework to go over. Number 8. Determine whether it is arithmetic, geometric, or neither. And then follow it up with, hey, it's arithmetic because D is this. Or, hey, it's geometric because R is this. So, what do you see in 8? Divide by 4? We don't have one that divides. Oh, it is geometric. Well, that means we need to know what r is. How you find r is you just take any number and divide it by the number before it. So if we take 5 and divide it by 20, because those are kind of nice numbers to work with, there it is, 1/4. Geometric. 9. What do you see that they're doing? Subtracting 3. What would that be? That would be arithmetic? So, what do we use for D? -3, yeah. Yep. 10. It's not working for either one? They're not adding the same amount every time or multiplying by the same thing every time? You're right. Neither, and walk away, because it's not following those patterns that we have. Ooh, this looks interesting. Use the given information to write an explicit arithmetic rule and then find a sub 10. Explicit arithmetic rule. Okay, it's got to have D in it and it has to have a plus in it. That's this one. All right. So let's see what we have, because we're supposed to put in the first term. Do we know the first term? We do. And we're supposed to have D. Do we know D? Rats. All right, so it's going to take a little more work, but we do have 2 other numbers, don't we? If you put a 6 in, you're supposed to get 32. If you put a 6 in, you're supposed to get 32. We can find D, and then we can write this puppy. So we have to put in what we have and do the algebra. What's 6 minus 1, everybody? 5. I think we know how to solve that. What do we do? Subtract 2. Then, now we know D. Now we can write it. So a sub n equals 2 plus n minus 1 times 6. But we won't leave it that way because that's not pretty. Chloe. Right here, if we put this little 6 in for n, we're supposed to get 32. Little 6 in, get 32. Alrighty, now we'll distribute the 6 and combine like terms. You getting what I'm getting? Okay, so that's going on the line that says explicit rule. But we're not done, which I'm glad there's a little blank there because we probably would have forgotten. We're supposed to figure out the 10th term. So what do?
Throw in that 10.
You sure do. A sub 10 equals 6 times 10 minus 4. What's 6 times 10? 60. Minus 4? 56. Well, that wasn't so bad. I think I'm going to stop there for today. Be a kind of an 11 and 11 split. So, anything that I had up here, I should check the time before I ask this, that you want another one of. You want me to make another problem up for anything that we did so far? Feeling pretty good? All right. So I'm going to get you your assignment, and know that this assignment is over 2 days. It's a 2-day assignment. It's just we're going to turn it in when we take the test.